Hi all, welcome back to ARR Education. My name is Reshman and today let us discuss about time and motion for grade 7. So, let us come to time first. You all are hearing about time from the time you were born. See, I use time in the phrase from the time you were born also. You are always scolded when you are late on time and always appreciated when you are early or on time. So, as you have heard this phrase many times, time is very important. So, what is the definition of time? Time is the indefinite continued progress of existence and events that occur in an apparently irreversible succession from the past through the present into the future. I know you won't understand that. But you do know what is time. As time is very important, we need to definitely know how to measure time. And to measure time, we know that we need clocks. So now, why don't we learn about clocks? So what is the definition of clock? A clock is a device used to measure time, as you know. So now, why don't we learn a little about the history of clocks also? Clock is one of the oldest inventions of mankind. Today, we have many types of modern clocks, such as smartwatches, watches, digital clocks, etc. But do you know about old clocks such as sundials, water clocks, candle clocks, etc.? Now I am going to explain you about them. So these are few images of them. This is a water clock, this is a candle clock, this is a sundial, this is a sun clock. So what is a sundial? A sundial is a device that tells the time of day when there is sunlight by the apparent position of the sun in the sky. To explain it in a simpler way, you know that the sun rises in the east and sets in the west. You see the sun moving around the sky by the time. So the position of the shadow differs by time to time in the day. As you can see, the shadow is just in a fast motion. That's why it moving a little faster, or else it would be very slow. So according to the position of the shadow, we understand the time of the day. The time is marked here according to the shadow's position. We understand this as you can see here. It's just the numbers are not marked here. That's it. So these are images of Jantar Mantars, which consists of sundials. You might have heard these Jantar Mantars. There are 5 Jantar Mantars around India, and they are very famous. They do consist of few sundials, uh, which we just talked about. So this is a table of conversion of units of measurement of time. Most of you might have seen this table many times, so I don't think so I need to again explain you this. So you might have heard of Galileo, the father of modern physics. He had even found the laws of pendulum, about which we are going to talk now. So first, let's talk about what is pendulum. Pendulum is a device that is used to measure time using periodic oscillation. The components of a pendulum are non-metallic body called a bob, an inextensible wire or string, and the point where the wire is hung or attached. So let me explain you how a pendulum works. It's very simple. So, as you see, the ball of this pendulum is continuously moving from one side to the other, and the ball goes to the other side like this and again comes back here. It is known as one oscillation. This oscillation is taken as one time period. The time taken for this oscillation is taken as one time period. For example, if this pendulum takes 2 seconds to complete oscillation, that means to go to the other side and return to its original position, it takes 2 seconds. Uh, and as the pendulum completes 10 oscillations, the time completed till now for it is 2 into 10 is 20 seconds. So like that you can calculate time in pendulum. But you might question that you can just count normal seconds. But if you are measuring longer durations of time, such as hours, it is difficult for you to count so much and you might get mistakes. If you make a pendulum which has a longer oscillation time period at 10 seconds, you will have to count less number of times. The chances of mistakes decrease. And for example, if the time taken for one complete oscillation can be made 10, you can make your pendulum in such a way. Or for even longer durations, even 100 seconds, 120 seconds, how much ever you want. So let me tell you about Galileo's observation on pendulum. Galileo found that the time taken for one complete oscillation of a pendulum was the same irrespective of the arc of the swing, the amplitude. That means even if you take the ball to more side and leave it there, the time period of the oscillation will be the same. Like you can see in this GIF, this ball is just left a little this side, and this ball a little more, this ball a little more, this ball a little more, and this the highest. So you might think that the time period for taken for one oscillation of each ball would be different, but actually it's the same. So it doesn't depend on the property amplitude. And the second property, the mass of the ball, as you can see here, has no effect on the time period. So even if the weight of the bob or the ball is higher, the time period of the oscillation will be the same. But as the length of the wire or string increases, the time period also increases. So in this diff, you can see that this longer pendulum is taking more time for one complete oscillation. This second one is taking a little long time, and this one is taking a very short time period. So if you want to make a pendulum which has a longer time period, you have to increase the length of the wire or the string. And if you want to make a pendulum which has a shorter time period, you need to decrease the length of the wire or the string. So, based on Galileo's findings, the first pendulum clock was invented by the Dutch scientist Christian Huygens in the year 1656. So, what about new clocks? The balance wheel. The pendulums were replaced by the balance wheel. The to and fro oscillation in the balance wheel is maintained by a balance spring, as you can see here. And the quartz watches and clocks. The balance wheels were again replaced by the latest quartz watches and clocks due to the efficiency of the vibrations of the quartz crystal, as the name suggests. In pendulum clocks, the number of oscillations were used to measure time, while in quartz watches and clocks, the vibrations of the quartz crystals are being used to measure time. That's it. So, if you question why not other metals, why only quartz, why not other minerals? Because in other metals, in other metals or minerals, the vibrations time period keeps decreasing rapidly. It isn't always the same. While quartz, even if in quartz watches and clocks also the time period keeps decreasing, but that decrease is very very less. That's why quartz is used. Yeah. So why don't we jump on to motion now? The action or process of moving or being moved is known as motion, as you all know. There are two types of motion. Uniform motion. When a body travels in a straight line and covers equal distances in equal intervals of time, it is said to exhibit uniform motion. So that means when an object maintains same speed always, it is known as uniform motion. Not even an increase or decrease in speed, but the same speed always. That is known as uniform motion. What about non-uniform motion? When a body travels in a curved line, it doesn't cover equal distances in equal intervals of time. It is said to exhibit non-uniform motion. So, when an object changes its speed time to time, it is known as non-uniform motion. So, why don't we jump onto speed now? You all know what is speed. Speed is the physical quantity which can be defined as the rate at which something moves. So, how do we calculate speed? The formula for calculating speed for objects traveling at uniform motion is speed is equal to distance divided by time. The formula for calculating speed for objects traveling at non-uniform motion is average speed. We are calculating here average speed because in non-uniform motion the speed changes from time to time. So we don't have any other option than taking average speed. Average speed is equal to total distance traveled in the journey by total time taken. The SI unit of speed is m/s, which is meters per second. Like kilometers per hour, we have meters per second, which tells you how many meters is an object traveling in a second. But this unit of speed is used for slower objects as it is a smaller unit of speed. For objects that move very fast, example airplanes, buses, etc., speed is usually expressed in kilometers per hour. So these are few examples which you can use to practice the formulas I just told you. You can pause the video to see and solve the examples. This one, this is another, this is another. So what is a speedometer and what is an odometer? Speedometer. It's a device used in vehicles like cars, scooters, buses, etc. to show the speed of the vehicle in kilometers per hour at any point of time. So it shows the current speed of the vehicle. And you must have traveled in any vehicle in your life. It may be a bus or a car or a bike, anything, and you might have observed that there is a meter in the vehicle which shows the speed of the vehicle so that you can know at how much speed is the vehicle traveling in. And what is an odometer? It's a device used in vehicles to show the total distance traveled till then in kilometers. The total distance the whole vehicle has traveled, the distance it shows, the odometer, and that is the odometer. So this reading is shown within the speedometer itself. It's a part of the speedometer group, not exactly the speedometer, but the speedometer group. So on the left, as you see, we have a distance time graph for uniform motion, and on the right, we have a table showing uniform motion of a scooter in a tabular format. It's a table, right? You can pause the video to have a look on them. So let us continue. So we need to calculate the speed of the object in kilometers per hour by the graph in the previous slide. See this graph and we need to now solve this question. So as this is a uniform motion, we need to use the formula I gave you for uniform motion. You can rewind the video to check that formula again. And that formula is speed is equal to distance by time, and we need to express it as kilometers per hour. So as we observe the graph here, it shows us that the object is traveling at 3 kilometers per 5 minutes. Here time is in minutes as there are 5 minute gaps. That means in 5 minutes it's 3 kilometers by, because it's 3, 6, 9, all multiples of 3. And here all multiples of 5. So it's 3 kilometers by 5 minutes. And we need to multiply 5 minutes into 60 to convert it into 5 hours, because you know that 1 hour is equal to 60 minutes. To convert 5 minutes into 5 hours, we need to multiply it by 60. And we need to even multiply 3 kilometers also by 60 to equal the fraction. Yes, fraction. I know this is physics, this is science, but some marks does come in physics. So we have to do it. A little max, not so much, not so complicated. So you can do it. In the fractions, when the denominator, which is 5, which is the down part, is multiplied by some number, the fraction is imbalanced. It is no more equal to the fraction 3 kilometers by 5 minutes. That's why to equal the fraction, we need to multiply 3 also by 60. And the numerator and denominator are multiplied by the same number, the fraction is still the same. The way we look at it is different, but it's the same. So at last we'll get 180 kilometers by 5 hours. Now to simplify the fraction, we need to divide the 180 kilometers by 5 hours. So we get 36 kilometers per 1 hour, or you can say 36 kilometers per hour, which is the answer. And simplifying the fraction doesn't change the final value, it doesn't change the fraction. We are just simplifying it to make it simpler. Like even 180 kilometers by 5 hours is the correct answer, but when you tell your brain it's 180 kilometers by 5 hours, it thinks as it a bigger value, like 180 kilometers is there. Even if 5 is there, it doesn't notice it so much. So when things are simpler, definitely it's easy for us to understand. That's why we are dividing it and making it 36 kilometers per hour. So the answer is 36 kilometers per hour, which is equal to 180 kilometers by 5 hours. So yeah, so now let's continue. So again, on the left, we have a distance time graph for non-uniform motion, not like the graph like before, not for uniform motion, but non-uniform motion. Now on the right, we have a table showing non-uniform motion of a scooter. So as it is a table, it is showing in tabular format. And you can pause the video again to have a look on them, because we are again going to have a question on this non-uniform motion on this graph again, like we had before for uniform motion. So now you just pause the video and after that you resume it and we'll see the question. So we need to calculate the speed of the object in kilometers per hour by the graph in the previous slide. This one, as I said before. And as this is non-uniform motion, we have to calculate the average speed, and the formula for average speed is equal to total distance traveled by total time taken. The total distance traveled here it shows as 9 kilometers in distance, and in time this line again corresponds straight to 30 minutes. So it's 9 kilometers by 30 minutes. And actually, I need to tell you one thing about these speed calculation formulas for uniform motion and non-uniform motion. You invite to see this formula for non-uniform motion and even uniform motion might look similar, but they're a little different. Yeah, but the formula for speed formula we are applying in non-uniform motion can be even applicable for uniform motion. And when it can be applicable for both of them, you are asking me why are we having a separate formula for uniform motion? Because when you do average speed, the numbers increase. Like you need to go to big numbers. Here it's just 9 and 30. But if you go a little bigger, you need to go to bigger numbers. But in uniform motion, if you use speed is equal to distance by time, it will go to a little less numbers. Like here only we are understanding the speed. So that's why we are having a separate formula for uniform motion. But the formula for uniform motion can only be applicable for uniform motion, not non-uniform motion. The formula for non-uniform motion can be applicable for both of them, but not the formula for a uniform motion. It can be only it's only applicable for uniform motion. So if you tell me to recommend formulas for non-uniform motion and uniform motion separately, for non-uniform motion, and obviously recommend average speed is equal to total distance traveled by total time taken, and for uniform motion speed is equal to distance by time. So I just wanted to tell you this, and that's it. So now let's continue in this sum. So, like we did before, we need to convert 30 minutes into hours according to the question. So, we need to multiply 30 minutes by 60 to convert it into 30 hours, as 1 hour is equal to 60 minutes. And we need to multiply 9 kilometers also by 60 to equal the fraction. And denominator, that is 30 minutes, is multiplied by a number. We need to multiply numerator also with the same number, which is 9 kilometers. So this only equals the fraction. So we even did that in the previous sum. Everything will be a little similar, just a little difference will be there for this calculation for uniform motion and non-uniform motion. So the fraction will be 9 kilometers into 60 by 30 hours, which gives us 540 kilometers by 30 hours. And to simplify the fraction, as I said, as we did it before, we need to divide the 540 kilometers by 30 hours. So we get 18 kilometers per 1 hour, or we can just say 18 kilometers per hour. So the answer is 18 kilometers per hour, which is even equal to 540 kilometers by 30 hours. And simplifying the fraction doesn't change the final value, so we can simplify it. 540 kilometers per 30 hours is equal to 18 kilometers per hour. You're just simplifying it to make it simple, to make it look simpler. So this is a question asking you to calculate the speed of an uniform motion object. So this and uniform motion, you again don't need to do total everything. So just need to do how we did in this sum. Can even rewind the video and check how we did that. Like that you have to do for this sum also. And the same speed, all that is given for in tabular format also, in graphical format also For if you want, you can do in graph or table. We did in graph, so you can do in graph. So you can just pause the video and solve the answer and comment down your answer in the comment section below. And if you get the correct answer, you comment that also in comment section again. So you just pause the video. After this, I will show you the answer. You resume the video, you will see the answer, and with that correct answer you can compare that video. I mean the answer. So this is the right answer, 20 meters per second. And don't forget to like, share, comment this video for me and your friends, because this can be helpful for them also. And subscribe my channel and click on the bell icon so that you can watch more videos like this and gain more knowledge to get good marks. You can watch this video again to be even more clear and clever. Hope you liked this video. Bye and have a great day.